Hi. So this is the problem is not a subset sum. This is the good problem, and this is the medium level problem in the GFG, and this is the POTD. So in that we just have to. The problem says that the whole problem is we need to find the smallest possible positive integers that cannot be formed using the sum of any subset of the array. A subset means we can take any elements, we can also skip elements. Each element can be used only once, right? So here the subset is, right? So this subset is, if you consider the subset, if is what, first is empty, second is 1, third is 2, fourth is 3, then 1 2, then 1 3, then 2 3, then 1 2 3, right? We can make all numbers from 1 to 6, right? And here the answer is 1 2 3 4 5 6 7 8, and we cannot take this and 1 2 3 4 5 6 7. The answer is 7, right? Now important observation is here, we can already make all the values from 0 to x. Now we see a new number, array of I, right? And there is a multiple of cases. So the case one, if if we have array of I greater than is equal to x plus 1, if this case, in then we can extend the range. All range is equal to 1 to x. By adding array of I, new sum becomes, and the new sum becomes is array of I to exceed of x plus array of I, this one, right? So the total reachable becomes 1 to the x plus array of I, right? So these all are them. And in that, if I will explain the multiples of the that means multiples type approaches. So the first approach is generate all subset sums, brute force, right? Generate every possible subset and store its sum, then start check from 1 upwards. First missing value is equal to answer. Example, right? 1 2 3, all subset sums 0 1 2 3 3 4 5 6, if we have to the 1 2 3, right? So this is now in that the recursion approach, very simple is a recursion approach. So if I need, like, recursion approach is, that means it will take the 2 to the power n exponential time recursion approach. So that is not taking here, right? And space is also take to the power exponential time. So I will not write the code, that is the very used number of clearly, so not go on there. Now go on the same in the dynamic approach, means in a recursion we just optimize and then we can make this dynamic approach, then it will optimize a little bit, right? So in that also an into sum, that is also a use complexity. Now just go on the optimal, that is the greedy approach, right? This is the best approaches. Now the main observation is we can already from all subset, right? Forms all subset, and then I just added here, I explain this. Now how to start the algorithm is basically sort the array. If we can sort the array, then start rest is equal to 1, traverse array of I to the rest, right? And then I just, that means compute the all and smallest missing sum, means I will just write the code and then you will definitely to understand what the problem says, right? So the problem is from array, I just comment out this all the things here and coming here. Now I just have not need to sort the array, and the sorting the array is array dot begin to array dot end, right? Now long dash is equal to 1, right? Now step 2 is version 4, int I is equal to 0, I greater than is equal to array dot size and I plus plus, right? And if array of I of res and then break. Right, now res plus is equal to array of I and then return res. Correct. Now I can check it will run or not. Yes, it will run. And try to submit. Yes, it will submit. So that is the optimal approach here, right? So this is the optimal approach here. In that, the time complexity is order of log n, right? N log n, and then this is the order of n. So we can say like the time is total n log n and space is order of 1, right? So this is, so I hope you will definitely understand the problem. If you have any confusion, you surely to comment out in the in comment section. I will surely reply on what the, and else if you have the another approach, then you will definitely to submit in our comment section. Thank you so much.